Welcome back, my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are in this part of this world. And as you know, this is the DADM, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. The course duration is for 12 weeks, which is basically 30 hours spread over 60 lectures, each lecture being for half an hour. And each week we have 5 lectures, and we are in the 7th week and the 34th lecture. That means with this one and the 35th one, we should be able to wrap up TOPSIS in all the details. Now, if you remember, so I will now move from the slide to the Excel sheet. So, if you remember, let me remove this one just. So, if you remember, we had done the normalization along the column. So, now let us change the first case, the type of normalization we are going to do. So, let me take, I will go a little bit slow here and then speed it up as we proceed. So, consider I am using the value very arbitrarily log this divided by sum log this second one plus log for the third one plus fourth one means I am talking about the cell position in the column. So, I close it. So, these are the values now. So, obviously, keep a look at this value because that should turn up to be 1. Now, this is 1 because normalization, if you see again second cell, third cell, fourth cell. I am not going to do it for the others for the time being. So, it can be done. So, obviously, the values have changed. Now, if I do normalization along the row, so I will do it for the simple case. So, this will be the first one divided by sum of all of them. It is row wise, remember. So, I should basically have the sum here as 1. So, let me first put it, so you can basically appreciate. So, this is done. So, I copy it. So, if you check, the values comes out to be 1. So, this can be implemented each year. So, if you follow the normalization along the row or the column, follow it throughout. And again you can use the different utility function to do that. Let me again come back to the slide. So, taking some normalization concept, I have these. Do not be too much bothered about the values in the cells, be bothered about the concept and use Excel sheet to understand that. Double check the second bullet point, that check each column adds up to 1 and it should be, because I am doing it column wise, it should have been, could have been also row wise, which I just showed. So, technically what would these values mean? These values would mean that on a normalized scale on 1, that means the total benefit, if you consider the first column, total benefit coming from criteria 1 is 100. Out of 100, alternative 1 is getting about 13%, alternative 2 is getting about 3%, alternative 2 and 3 is getting about 30% and alternative 4 is getting about 53%. So, if there are resources, they are being distributed in the ratio of 13 is to 3 is to 30 is to 53. Similarly, if I come to the last column for the fifth this criteria, then the corresponding so called weightages or values which are accruing to alternative 1, 2, 3, 4 are correspondingly given as I should use the pen color to making, are these 50% for first, 22% for the second, 22% for the third and 5% for the fourth. I am not reading the decimal values. So, this is the normalized matrix which I have. Now, the decision maker has to make a decision about the weights, that means the weights which he or she thinks each and every criteria would accrue, the importance, relative importance of the weights by themselves, within themselves, such that the values which they are giving for each and every alternative would be multiplied by the corresponding weights to make a ranking corresponding to that. Because till now I am only considering the values which are there in the matrix R are for each and every criteria on a standalone basis. So, if I only consider the first column, I am not considering the other 4 criteria. If I am considering the third column, I am not considering the criteria 1, 2, 4, 5. If I am considering the fifth column, I am not considering criteria 1, 2, 3, 4. But now with the weights, I will basically weight them up and give a priority. So, these weights would basically give you the priority amongst the criteria themselves. So, if the decision maker decides on the sets of weights depending on his or her preference, the weights would be given by the matrix of size n cross n, where the principal diagonal would be the weights W1 to Wn, all the other than principal diagonal the value should be 0. And one should remember that the sum of the weights is 1, as it should be 1 or 100, 200, but it should basically be normalized. So, if it is 200, again you divide by 200, it comes back to 1. So, the weights are given, which are for this problem 20% for criteria 1, 10% for criteria 2. So, let me mark the principal diagonal. So, then the third value 15% for criteria 3, 25% for criteria 4 and 30% for criteria 5. So, now see here, this matrix is of size 5 cross 5, which is basically n cross n, which corresponds to the number of criteria which you have, nothing to do with the m value, which is the number of alternatives. Now, I multiply the value of R into W, that means I am trying to now bring a parity or a normalized scale for each and every criteria along with the concept of the alternatives. That means, alternatives weights have been found out normalized, then I am also ranking the criteria such that I find out a ranked normalized score or a matrix for each and every alternative with respect to the criteria. So, I multiply this m cross n multiplied by this n cross n. So, the actual value which I will have, I mentioned it time and again, but still I write it. So, when you do that, matrix R is m cross n, it will be multiplied by W, which is n cross n. The actual value V would be m cross n now. So, as it should be. So, this R is given here, this W is basically given here, and this, say for example, V once you find out is given here. So, you find it out accordingly. Now, what you need to do is that you need to find out the values of positive concept and the negative concept. I am only considering, you remember in the last lecture, which was in the 33rd lecture, I did mention that I will only consider the concepts of 4 columns, which is positive, negative, benefit corresponding to how close it is to the positive ideal solution, and then again positive, negative corresponding to the fact how close it is to the negative solution. So, I will keep repeating it in order to make you understand. So, I will only consider the first and the third column. I am not going to consider the fourth and the fifth. They can be, but there the steps of calculation will be too much. So, I will proceed accordingly. So, we will consider V plus, plus means the ideal solution, which says as it is. So, which is the most positive ideal solution. So, we are now determining the most positive ideal solution and also the most negative ideal solution. We will come to that. So, V plus would be the maximum. So, if you consider either the row or the column, you will consider the maximum of these values. So, the concept whether you will consider either the row or the column would depend on the fact that which type of normalization have you done. That means, either the row 1 or the column 1. So, follow 1 general rule such there is parity. So, for each m, that means I am doing for each of these alternatives, I try to find out the maximum for all the number of criteria which are there, and I will write these values. So, write these values for the I is equal to 1, I have V 1 plus. So, this will be for I is equal to 1. When I go to I is equal to 2 is equal to V 2 plus. Similarly, when I go to I is equal to n, for each values I am calculating. So, I am getting the j value. So, I have basically the values corresponding to I is equal to the j value would be coming out. So, they would be, because technically should be j. So, I find out V n plus. Similarly, I will calculate the V minus negative values corresponding to the most negative ideal solution. So, it will be the minimum. So, I have the maximum and the minimum corresponding to the ideal set. Then similarly, I have the maximum minimum corresponding to the non-ideal set, but I am only considering the first and the third column which I mentioned. So, here I find out the minimum values corresponding to j 1, 2 for all the sets of j's. So, it will be done corresponding to all the values. So, I will find it out and then write it down as V 1 minus, V 2 minus. The minus sign on the top basically gives you the non-ideal, or sorry, the negative ideal one. So, if you remember the PIS and the NIS, positive ideal solution and negative ideal solution. So, once you have that, you will basically find out the distance function. So, distance function for each would be for each of the cell, those that matrix V I ij which I have, which is of size m cross n. So, each cell value would give me the the point in the coordinate system where it is placed with respect to each and every criteria and each and every alternative. So, you will try to find out the maximum the ideal one, best one, you will try to find out how close you are. So, say for example, I try to give a pictorial one. So, consider best would be green. So, consider the best one which is maximum is green here, and I am considering the real line. So, what I have the real line, this is the positive solution. So, this is positive and go further you go. Now, we will consider each and every criteria. So, consider I will write it using black. So, consider the first one is here, the second one is here, I am not using the colors, I am using the numbers only, third one is here, fourth one is here. So, what I am trying to find out is that I am giving the finding of the weight. So, I will find out the difference between first and the green solution, square it up. Second, then find out the difference between the second and the green solution. Green is the most positive, square it up. Find out the difference between the third and the green solution, square it up, and find out the difference between the fourth and the green solution, square it up. So, these are the distance function. Once you have that, add them up, find out the so called average square root. So, it will gives you a so called weighted average, and weights corresponding to the fact would be equally weighted, because you are not basically penalizing anything. So, you will basically find it for all I is equal to 1 to m. Now, as you have done for the positive one, you will have the negative ideal solution also, and need to find out the most negative value, which is S ith star for each and every I 1, 2, 3 till m. So, you will basically have the number line. So, I will first mark the negative one as red, because I am trying to follow that policy of red being. So, consider the red one is here. So, I am not comparing the green point with the red point. So, if I have to do, I have to draw the real line actually and mark the green and red. I am considering them separately. Consider 1, 2, 3, 4. Now, in the earlier diagram when it was the green one, those distances were nice to me, good, closer it is better for me, but now further I am better for me, closer it is bad for me. So, I find out the difference between the first and the red one, square it up, then find out the difference between the red and the second one, square it up, find the difference between the third and the red one, square it up, find out the difference between fourth and the red one, square it up. So, this is again equity penalized one, finding out the differences, squaring them in the Cartesian sense and then adding up and find. This is basically the simple distance which I am trying to find out. I do it for each and every this alternative and find out S1 till Sm plus. Similarly, I find out from S1 to Sm minus. Minus and plus are on the top. Now, once I have that, I find out the relative proximity. So, how far and close it is. So, this would be very simple in the sense I have some positive Si pluses are already there, then I also have the Si minus. So, I will calculate the proximity. So, I am only using one set of calculation, I am using Si minus. It could have been done in different ways. So, it could have been done, I am just mentioning I am using the concept of. So, this is what is given, I will first write and then write out the different ways of trying to find out the proximity values. So, this would be I am using, so I will write it down and then compare x I minus so if this the calculation is done, the value is given here. Now, if I do a separate type of calculation which would be, note it down carefully, Si plus Si plus minus. So, I will have a second set of proximity values. Now, this I have done how close or far they are. So, I found out the maximum corresponding to that. Now, if I want to find out the minimum. So, if you remember I found out the max of the closeness. So, I could have done for the positive one. So, the positive one we were doing max, and for the negative one we were doing the min. I will write it in the colored part. So, you doing the max positive benefit. So, based on these we will obtain this. Remember, the cell values which I have here are based on these concepts. This has nothing to do here, we will change it, you can find it out. What you can do is that you try to find out the minimum and the maximum for these cases. Now, these would be which is not done in the calculation for the problem, but I am just mentioning it. You find these values, I am now using the colored black. So, because it will be, or I can use a different color, I will try to a different shade. So, this would be minimum for the maximum case, and this would be maximum or the minimum case. So, if you find out technically, so you will basically have one set of Si minus divided by Si plus Si minus for the first comparison max min with color dark green and red, blood red. Then based on dark green and blood red, you can also have Si plus divided by Si plus Si minus. That is the second methodology, which is basically would give you the second column. When I use the light green for finding on the minimization and a dark brown sort of thing, a blackish red for the color, it will give you the maximum. So, that will be the maximum of the distance which is there from the negative sense, that is further it is good, but whether it is positive I do not know. Negativity is decreasing, whether it is giving positive values I do not know. So, based on that min and max which is on the second stage, I will basically have again Si minus divided by Si plus Si minus. Again I have this fourth one, which is the fourth column, which will Si plus divided by Si plus Si minus. So, I can mention them as 1, 2, mention them as A, B, and what I will have the combination is 1 with A, 1 with B, then also I can have 2 with A and 2 with B. So, I have here and here. So, this will give me 4 different proximity values. I am only considering one of them. Now, we will start a simple problem. Problem is, let me give you the background. Consider the problem is related to buying a house and apartment among 4 choices in any city, but I also consider that the city's preference is also under my jurisdiction, where the decision to buy the house and apartment is based on the fact there are 11 different parameters criteria, which are which city you want to buy, what is the price of the house, what is the loan availability, conditions of loan, where is the location in that city, number of rooms which are there for the house, how many bedrooms, kitchen, drawing room, so on and so forth, guest room, what is the safety of that apartment, how safe is the apartment, whether there are security guards for that to taking care, whether the security service is there, CCTV is there, people are definitely would be bothered about that. Whether it is a gated community, whether the people who are come, strangers are asked whether they want to go, a register is maintained for that. So, also you will be interested to know when you buy that house and apartment, what is the proximity to the markets of that apartment house. So, you want to buy a few things, daily consumption, rice, sugar, coffee, tea, any vegetables, potato, tomatoes, whatever, how close it is, you want to immediately get it. Then say for example, the person is buying that house and he or she has kids who are in school or in colleges. So, you want the schools and the colleges to be near, so that they do not spend too much time in commuting. So, you will also find out the proximity of that apartment or the house to the schools. I am just using the word school, it may be the education hub, to tuition, coaching center, the kid go to say for example, to learn different music, some from Hindustan classical music, or say for example, Odissi dance, Kathak, whatever. Then you will try to find out how close or far is it the proximity of the hospitals. So, because old parents are there with you, you need medication, or say for example, you suffer from fever because the weather change affects you. So, or your family members. So, you want to be close as far as possible close to the good hospitals or doctors, whatever it is. What are the facilities available? If it is a guarded community, so obviously you would like to have, nowadays people want a swimming pool and say for example, small auditorium, a community center, there should be a walking space, there would be a space for the old age, old people to sit down and talk amongst themselves. So, you like that to happen. And say for example, you also want to find out what is the resale value conditions. Is it that if you sell that house, you have to pay some amount of money as a caution money or something of the sort to the cooperative or to the broker. So, obviously, those can be managed, but you would also like to know about that. So, now here the apartments numbers is 4, which is m is equal to 4, that means 1, 2, 3, 4 number of alternatives are there, A1, A2, A3, A4, and the criteria are 11 in number, C1, C2, C3, C4, C5, C6, C7, C8, C9, C10 and C11, 11 of them are there, which is n is 11. So, you will based on that you want to proceed and find out the ranking system. Now, let us consider the matrix of priority 1 is given to you. Obviously, you can do that, as if you remember for the concepts of AHP or analytical hierarchy process, one can ask questions and then find out the values. So, I am just considering the values as it is given. So, they are, if you consider I am only read one of the row, which is basically the first row. So, values are 45.5, 40, 66.7, 9.2, 1.8, 0, 1.3, 2.3, 1.6, 4.8 and 3.1, which means that if I take this value of 1.3, it means for the first house the 7th important factor. So, let us see, let me go back to the first slide. 7th important 1, 2, 3, 4, 5, 6, 7, proximity to the markets gives you a value, so called value of 1.3. So, if similarly maybe if I consider, let us consider the 0 0, maybe the 7th one, sorry, so the 7th one for house number 2, which is proximity to the markets, and house number 3 are does not matter, they give you a 0 value, consider they are very far off. So, obviously, you will not be getting any value, and closer it is you are getting the benefit. So, these values are given and you want to normalize them. The normalization factor, again I will use the same concept, that is any cell value divided by the square root of the sum of the squares. And with this I will end this 34th lecture and try to wrap up with the 35th lecture the overall problem of how, when you are trying to buy a house, how you will rank them. Have a nice day and thank you very much for your attention.